Okay, let's begin lecture. Just a couple things to go over with you on this screen. Every day, every lecture, other than exam days, we'll have a screen like this. This is the intro screen. You'll see on the right over here the basic outline, at least at the level of capital Roman numerals for the day. And sometimes we don't finish with it. And we have to use it for the next day. But we usually cover everything on the outline as much as we can. Over here, every month I have a different guest quotation. So month of September is Martin Luther King Jr. August was Galileo. We'll have other famous people giving quotes of the day. Office hours. Now, last Wednesday, I blew it. Well, I didn't blow it, but I hurt my back doing yard work, so I couldn't go to office hours. But hopefully we'll have office hours tomorrow, 9 o'clock to noon. Right next door in the Physical Sciences building, go in the main entrance, and room 158 is right as you go in the main entrance. Look to your left and just head that way, and you'll see a big sunroom, a solarium, with a bunch of tables and a couple marker boards and stuff, and that's where we hold our office hours in lecture, or excuse me, on Wednesdays. My regular office is 2 doors away from that, room 156, but it's pretty small. So, but you come to office hours. We'll talk about anything you need to talk about, homework, anything else, grades, blah blah blah, anything. All right, couple housekeeping details that we want to go over about the textbook. I noticed that a student was saying, "Oh, Dr. B, I couldn't get it downloaded from Kendall Hunt. It was giving me problems." Vitalsource.com is where you go if you have that card. Raise your hand if you bought a card at the bookstore and used that. Okay, that's what I use the card. Raise your hand if you went straight to kendallhunt.com and got your book that way. All right. I hope that you got the bookshelf application. It seems to be pretty nice. I've got it on my laptop. I believe you could put it on your iPhone or your Android as well for accessing the ebook. It seems to have some nice features like reading aloud. The other thing I like, and I've just started using it last night, the other thing I like is the highlights. So if I highlight part of the textbook, it appears that I'll be able to share it with you guys. If you're also on the Bookshelf app. Now, I'm not sure exactly how it works, but I'm going to start sharing with Darianne as soon as possible, as soon as she gets set up with it. And then hopefully you guys will be able to share and look at my highlights. And the reason that that's important is, A, I wrote the book, and B, the part of the book that I didn't write, I'm the instructor for that part of the book as well. All right, so half and half. My notes, my highlights, and comments on the text, you might just want to look at those if you can. If you can't, you can't. But if we can get this thing working good, it'll be very, very helpful for you, because I made some notes in the text this morning as I was getting ready for lecture. So hopefully that'll be good. Does anybody have a question about the e-text before we continue? Okay, let's keep going. iClickers. Student put a discussion posting. I couldn't get into iClicker and register. I have some hopefully good news for you about that. This is the page that you're supposed to get when you hit the iClicker link over here on the left. All right. This is the only place that you're allowed to register for my class. And we're not using the reef business, at least not now. To start the semester, we're doing straight iClicker, you have to use this. Now, the good news is that out of 600 students, only about 116 are not registered. Okay? And I just synchronize the roster. So when I synchronize the roster, it tells me, you know, my roster that the registrar gives me. When you register your iClicker, now just like a little grade associated with your NID is a serial number for your iClicker. And when you click in class, your clicker sends me your serial number and then your answer, whatever you're clicking. Okay, so I'm able to figure out, okay, when such and such a serial number clicks in class and I get it here, I now know who it was that clicked that because they're on my roster. And so when I synchronize the roster, I can see who's registered and who's not. And so far, only 100, or as of this morning, only 116 out of 600 or so are not registered. So that's good. I'm happy about that. Now, the other thing I noticed, some of you reported a little bit of difficulty. When I tried it this morning, I got a blank page. And then after a few seconds, I noticed that this page not miraculously, not mysteriously, but nicely and wonderfully appeared. So I think it takes a few seconds to load. I also noticed that it's sensitive to whether you have cookies enabled. So if you're in Safari, which is what I normally use for almost everything, you have to go into preferences and set cookies to be allowed from every website. And I think it'll refuse to load this page if you have cookies completely disabled. So if you prefer to have cookies completely disabled, enable them for this website, register, and get the little feedback. You know, as soon as you register, it'll say, you know, registered on such and such a date and your clicker serial number and stuff. And do that, and then go back to preferences and set it back to whatever you want. You know, no cookies or whatever your preferred setting is. And then that'll be good. You'll get the job done. So hopefully, with a little bit of patience, if you're not registered, you can get registered today. All right. Now, in regard to bonus points, I said that Tuesday last week, Thursday last week, if you were registered and stuff, you'd get a bonus point, and I meant it. And I posted those last Friday, I think, and some students within minutes texted me in conversations on web courses and said, Dr. B, why is my grade now down to a 60% because I didn't have my iClicker? So those students were dibbling around with this set of gray rectangles at the bottom of the grades page. Now, you may have noticed those down there. They have a bunch of percentages, and those percentages down there have nothing to do. I don't set them. I don't tell web courses how to do it. And the way web courses is, it's either their way or the highway. The problem is that because I don't set those percentages, the mechanism for that, web courses does whatever willy-nilly it wants to do, and so it's completely inaccurate and misleading. This stuff up here is, okay, your points over here, I control all this. And these upper few lines, the bonus points in the exams, they all have false due dates. I set the due date to, before classes started so that I can put everything up at the top of the grades page. So I always like to have bonus points and exams at the top of the grades page. Then down towards the bottom, the homeworks they'll fall in with accurate due dates, which is reflected here in this center column. But all these center column due dates here are phony, so that I can have all of them up at the top of the page. Now, down at the bottom of the page is the stuff that I don't want you to look at. So this stuff down here has nothing to do with our grades. The points above there, like 3 points on homework 2 and exams points and stuff like that. Those have to do with our grade. But I never set this to do anything. And the problem is nobody at UCF knows how to turn it off. So you can't, I've asked like a zillion different people. Nobody knows how to deactivate this gray rectangle and all these foolish percentages down here. So look at this. I've got a total of 60%. That's 60% is misleading. And that's my grades. And all I have on the books is bonus points. So if you have bonus points on the books, how can you possibly have less than 100%? Bonus points, you're automatically 100% or higher. So it's completely inaccurate. Do not pay attention to that. And especially do not ask me questions about it, because I'm just going to say, read carefully right here. Pay no attention to the grades and percentages in the gray rectangles at the bottom of your grades page. Also, the grades drop-down menu that you have at the top of your web courses, I can't see that the way you guys can, but the grades in there are percentage-based. That is incorrect as well. Or it's not incorrect, it's misleading. It has nothing to do with my grading. I never give you guys a grade in a percentage anyways. I go by points and only by points. So as far as that goes, this top of the page is all you need to look at. The points up here in this column, your score, that's just add those up and you can figure out what your grade is. I never put a percentage up for you guys ever, but Web Courses does, and it's a menace to navigation. So just ignore that stuff down there, and your life will be considerably less complicated and less worrisome. You'll have less worries. All right? Now, let's try a clicker question. Turn your clicker on, and I want you to see if you get the Go Nitro message. You should be on frequency BB. Bravo, bravo. Now, if you don't have that frequency, press the power button down and hold it until the square flashes. Okay? And then when the square flashes, type in B and then B again. And then you'll get the Go Nitro message. Raise your hand if you just got a Go Nitro. Woo, doggies, look at that. All right, so if you got a Go Nitro, you're cooking. Yeah, Colin. All right, so what that means is I've got your clicker data, but I don't know that it's your NID. So, and if you're not registered, it'll collect your data, but it just has a serial number, but it doesn't have your NID attached to it. Okay, until you register. Okay, so try to do it after class, and I'll be updating the roster probably tonight from home, and then I'll be doing bonus points. So if you get it done after class, you'll get a bonus point for today. All right. Now we have a high-level Chuck Norris question. And I want you to read it very carefully, because the fate of the Western world depends, as you know, on Chuck Norris. All right, so let's see. Okay, you should be able to vote now. Which is the most important Chuck Norris concept? Concept A, little kids wear Superman PJs. Superman wears Chuck Norris PJs. Concept B, outer space exists because it is afraid to set foot on the same planet as Chuck Norris. Concept C, Chuck Norris has already been to Mars, which explains why there's no signs of life there. Concept D, they found Chuck Norris's diary. It is now known as the Guinness Book of World Records. All right, 15 seconds to vote. Excuse me. Ah. Yeah. Okay. The question up here was, do we click send after hitting a letter? The answer is, on multiple choice, no, you don't have to. If it's my software knows that it's asking a multiple choice question. Therefore, as soon as you click, it'll be sent. All right? Now, We're going to use questions a little bit later this semester where you type in the number, like 24.6 meters per second for a speed or something like that. So you're going to type in 24.6, and that a numeric or an alphanumeric where you type in some letters, you have to hit the send. But for multiple choice like this, just click it and it's good. So if you got a check, and in general, if you have a check mark, that means not only has it been sent, but I've sent you a confirmation. My computer sends the check marks. Okay, so if you got one, that means, ching, we got it. All right, so I want an extra minute here on that question. Let's see what, Hey, who voted for option E? I don't know if I'm getting through to you guys. Anyways, let's look at the vote. So here's the vote. The majority. That is my former favorite Chuck Norris fact. My new favorite is this one down here. But it's a Chuck Norris question, so everybody gets a point on that. Anyways, it's a fun question. And so you have now done your first. For a lot of you, that's your first actual Chuck Norris, or your first actual iClicker question. Now we're going to have a regular question in a few minutes because we're now going to turn back to physics concepts. And we're going to do some velocity stuff today. Last time we talked about wind shear, which is really a tale of velocities at two different altitudes in the atmosphere. We had homework, and I think some of you had a hard time finding Florida on this. And I did too. You have to almost use your x-ray vision to see it. I posted another picture, a little less saturated, and Florida is right up here in this diagram. I don't know, it's kind of hard to see, and Cape Cod's up here. But really the questions were about the colors. The real question was, could you read this color scale down here? That was the only real question you could do. Anyways, the reason it's hard is these wind barbs, as they're called. Now, if you look at the Channel 9 news, the weather, or the Weather Channel sometimes, they have charts of the wind flow at a given time or a forecast for a given time of day. And they use arrows, okay? The weather chart that we looked at uses what are called wind barbs. And these little tail feathers here, it's like an arrow with tail feathers. And the number and size tells you the speed of the wind at that particular location. So it was kind of hard to see. But the interesting thing is they express accurately, pretty accurately anyways, a velocity vector. And vector is a vocabulary word that we're all going to need to know. V-E-C-T-O-R, vector. And what vector is, it's a generic term for a quantity that must be encoded with a direction. Now, here's an example. When you go to the store, if you go to not Safeway, but Walmart, Superstore down here on Alafaya, or if you go to Publix and buy some submarine sandwiches, you don't go in there and say, well, I'll take the chicken tender submarine sandwich. By the way, has anybody had the Publix chicken tender sandwich? That thing is good, really good, and a lot of meat on it. And I every time it's on special, I get it. That thing's good. Anyway, so you don't go in there and you say, yeah, I'll have 2 submarines, so the quantity is 2. I'll have 2 chicken tender submarines northwest. You don't say that. You just say, give me 2. That's a quantity without a direction. You don't go in and say, well, I got to buy a dozen eggs southeast. You just say, I got to buy a dozen eggs. That's a quantity. And the fancy word for that is scalar. S-C-A-L-A-R. A scalar quantity is an adequate description, a numerical quantity that does not need a direction. But a velocity, if you're out on the turnpike, your GPS is computing your velocity all the time. You know, you're going 65 miles. You're a good young man. You're a nice young lady. You're not breaking the speed law. I know everybody in here obeys the speed law at all times. So I know you never. If it says 65, I know you're never above that. 65, and it's also going to give you a direction. So if you're heading for Miami, your direction is going to be southeast. But if instead your direction is northwest, you ain't going to make it to Miami. You're going to have to turn around. All right? So a velocity tells you where and how fast. That is an accurate and complete description of the motion at a given instant of time at any rate. All right? So this concept of vector is something that a physical quantity that requires a direction as well as a quantity. Right? Now, we're going to tackle this concept of motion, a speed and a velocity, and a direction using skateboards. Now, we don't have any talented dogs like this guy. Have you ever seen this guy skateboarding? It's pretty cool. So we can't have him for a guest speaker, so we're going to have to use a couple other students with skateboards. And what we're going to do is measure the velocity down here on this aisle as they go down the aisle. And what we're going to see is that, we're going to see different things. And that brings me to the first pull quote. This is actually a pull quote from the textbook. What does the observer see? This is the central question, or I should say the primary question of the scientific enterprise. The scientific enterprise is all about what we can observe. What does the observer see? And then hopefully it's something that he can, if he has a good device, he can measure it. You know, with a meter stick or with a timer. You know that pendulum we had the other day? That's a primitive timer. A grandfather clock, tick, tock, tick, tock. 1 second for every swing. That thing that we had, it was built, the length of it, 1 meter, is just about perfect for a 1 second. 1 second to the right, 1 second back to the left. Tick, tock, tick. So that's a timer. And we have timers on our clocks, our watches. Now I'm gonna ask for timers up here on the aisle. You guys on the aisle here, do you have a phone? Yeah.
I'm not a student though.
You're not?
Yeah.
What are you doing?
I'm from SAS, writing a transcript for a student class.
Oh, check. Okay. What?
Sorry?
You're doing the transcript? Did you just type what I said?
Well, she isn't. So you're talking.
There's 2 of yous. Sweet. All right. All right, so we're going to have to, you're in the perfect position for measuring. Okay, Cody, have you got an iPhone? A timer. You know how to use the timer? Okay. Young lady behind Cody, do you have an iPhone? Everybody's got phones, I know, smartphones. All right, you guys up the aisle. I'm going to come up here in just a second, and we're going to try to set up observation posts and measure time intervals. And then we're going to get a couple skateboarders to come down and skate. All right, so let's put a timeout on the lecture, the recorded part of the lecture, and let's do some measurements. And then when we're done with that, we're going to go to the document cam and get it all organized and stuff. Okay, so let's make some measurements, and let me pause the podcast. And hey, get my cursor here. All right, now let's get the data on the document camera. And am I on the document cam? Okay. All right. Let's see. Today's September 1st, 2015. And skateboard motion experiment number 1. First one is Colin, and let's see. Let's make a table here. First observer is Caitlin. Caitlin it's Kailin. Okay. And then Darion, how do I spell your name? Darr. I can't hear you. Y. Okay. Okay, Darion. And time. Now, Caitlin is always going to be 0.00 seconds. All right, because she's the starter. She's the one. She's the one at Kennedy Space Center that gets to press the button. You know when the countdown 10, 9, 8. It's somebody gets to press the button to launch the rocket. Pretty cool, huh, Caitlin? All right, Omari. How do you spell your name? Okay, Omari. Omari. And then Cody, how do you spell your name? Cody for Cody. And then last is Maddie, and I already asked how to spell that one. All right. Okay, for column number 1, Darion. And speak loudly, because I got this fan back here we can't turn off, so you're column number 1 time. 2.26, 2.46. Okay. Omari. 3.45. Okay. 3.45. Cody. 4.53. Maddie. 5.25. Okay, and I'll label this in seconds up here. Okay, now let's get the distances. This is the position. Now notice these aren't elapsed times. These are only time measurements. We're basically figuring out where on the clock he was when he passed by Maddie, Cody, Omari, and Darion. And we know where he was with Caitlin. Okay, so Caitlin's position is 0.00 meters. And Darion is, now what was that? 1.83? 1.83. And the next one was 108 inches from Darion to, so what was 2.7? So what's 2.74 plus 1.83? That's 4.57. 2.74 plus 1.83. Okay, who's got it? Okay, 4.57 meters. That's his position. So the origin of coordinates is back there at Caitlin, at least for the x-axis. Okay, and then it gets bigger as we go down the hill. Cody is another 2.74. So 4.57 plus 2.74. 7.31. Dude, did that in my head. 7.31. Okay. And so Maddie, now these positions are going to be the same for each run as well. So we only have to figure this out once. Okay, 7.31 plus 2.74 is 10.05? 10.05? Okay, so let's write that 10.1. 3 significant figures. Okay, it should be 10.05, but we're up in there, up above 10 now, so we have to just slightly above 10. All right, so they're my positions. All right. Now let's get it down for Stephen, number 1. Okay. So we're going to go Caitlin, K, Darion, D, Omari, O, Cody, C, Maddie, M. All right. Now, the positions are all the same, but the times are going to be different, except one time is always the same, and that's Stephanie. Or that, excuse me, that's Caitlin up here. 0.00 seconds. All right. Darion, Stephen, measurement number 1. 2.23. Okay. Omari, Stephen, number 1. 3.4 flat. Okay, so write that down as 3.40. Cody, Stephen, number 1. 4.33. Okay, Maddie, Stephen, number 1. 4.85. Whoa! Who was moving faster? Stephen, because it took him less time. See, whenever we're making observations and recording some numbers, we can extract from that some kind of a message, and that's what we've already extracted a little bit. Stephen was faster. We're going to extract more from this data as we go through. All right, let's put in the distance or the positions. 0.00, 1.83. This one just copy 4.57, 7.31, 10.1. Okay. All right, I'm running out of room here. I'm going to have to compress. Okay, column number 2. Can you see this now? I don't have the, is this visible? Okay. All right, let's go with column number 2. Okay. Caitlin, Darion, Omari, Cody, Maddie. Okay. Caitlin with a K, Darion, Omari, Cody, Maddie. Okay, let's get the times. Caitlin, 0.00, that's always the same, because she's the starter. She gets to press the button to blast off. Okay, Darion, column number 2. 2.53. Omari, 3.71. Cody, Stephen, column number 2. 4.81. Okay. Maddie. 5.63. Okay. All right. And just copy down the positions. 1.83, 4.57, 7.31, 10.1. Okay, last one, Stephen number 2. Okay, let's see if I can squeeze this in here. Caitlin, Darion, Omari, Cody, Maddie. Caitlin, Darion, Omari, Cody, Maddie. Okay, Caitlin is always 0.00. Darion, Stephen number 2. 1.89. Okay, 1.89 seconds. Omari, Stephen number 2. 2.86. Stephen is blazing over here. Look at those numbers. Okay, Cody, Stephen number 2. 3.88. Maddie, last one. 4.70. Okay, and positions are the same. You know, Caitlin, you don't have very exciting numbers, but you get to be the one that presses the blast off button, so that's good. And these other guys are the working man, the working woman of the scientific world. All right. Now, what we're going to do next is we're going to start extracting some information from this table. But before we go on, I want to ask you another clicker question. So have your clickers out. Again, we're going to be on frequency BB. Let me swap over to laptop. Do we have the laptop now? Do we have the laptop display? A little white dog with a kind of befuddled? All right. All right, now that we just did this. We used the document cam to organize our data. And now I want to extract information. And to do that, we're going to look at our... now, this is a regular physics question. This is not a Chuck Norris goofy question. This is the real thing. All right, so let me start the question. And here it is. How do you combine distance and time measurements to calculate speed? And read very carefully. And when you've read carefully, make a vote. And this is multiple choice, so as soon as you click an answer, and you could change your answer if you want. If you vote for A, and then you decide, oh, I'd rather vote for C, just do it. You know, you can change it. It's not a problem. 15 seconds. Five, four, three, two, 1, 0. Okay. And you know, there's 150 people just voted, 152, which is great. That means the by far the majority of this class is clicking, and hopefully you'll be all registered up by the end of today. All right, the correct answer. Let's see what you guys voted for. Okay, here's the vote, and some of you took this multiplication. No, the correct answer is actually the ratio. And here's a way to think about that. Anytime you are just telling someone the speed of something, you have to give, for instance, miles per hour. That's distance divided by time. Okay? And this is the only distance divided by time thing up here. The ratio of the distance d to the time interval delta t. Okay? And students, this notation delta t means the difference between two time measurements, which is what we're going to do on document cam right now. We're going to calculate delta t and then distances d. By the way, this, let me move this out of the way here. This particular answer here, delta t quantity squared minus d squared, it does look like Pythagorean theorem, and guess where we use this? We use it in the theory of relativity. This is the version of Pythagorean theorem that you use in four-dimensional space-time. But for us, doing a simple distance and speed calculation, this is the one that we want to use. All right, now let's draw the message out of this data. And let's go back to the document cam and do a couple quick calculations. All right. Do you have the document cam again? Okay. All right. Now take out your calculator and let's just do, we're going to do column number 1. And then for homework, what I'll do is I'll scan this page from into PDF, and then I'll put it on web courses, and you can recopy it or double check it, or people that aren't here, they can listen to a lecture and work out the calculations. You're going to be doing homework based on this stuff down here. Okay, well, we're going to do column number 1, and the first thing that we're going to do is figure out delta t from here to here, from Caitlin to Darion, and basically delta t, let me write it down here, delta t is t2 minus t1. It's the difference, t2 minus t1. It's the later time minus the earlier time. It's basically an elapsed time. And the terminology or the symbol, Greek capital letter delta, it's delta for difference, D for delta, delta for difference. And a difference is a subtraction. So, and it's always later minus earlier. So T2 minus T1, T final minus T initial, and we can do delta X's as well. Anyways, let's do delta T. 2.46 minus 0 is easy. So for the two events, the start at Caitlin and the moment that Colin passed by Darion, the time interval was 2.46 seconds. All right, so let's label this column seconds. This column should be M for meters. All right. Now, from Darion down to Omari for column number 1, 3.45 minus 2.46. What is that? 0.99? Come on, verify me. Okay, 0.99 seconds. Okay, we'll go out to hundredths place. All right, from Omari down to Cody, 4.53 minus 3.45. Ooh, that's 1.08. Okay, 1.08. And then from Cody down to Maddie, it's 5. Whoa. That's 4767. So that's 0.72. 0.72. Okay. All right. Now, delta X. All right. Between the two events, Caitlin and Darion, it's 1.83 meters. That's the easy one. Okay. Now, from Darion to Omari, what was that, 2.74? Okay, so these ones are all going to be 2.74 all the way down. All right, because we had a bunch of what was it, 108 meters? No, yeah, and so we had three the same, and then the last one was a little shorter. Okay, last thing, average speed. Now this one, we're going to use that formula. Okay, now I'm going to do a couple. Ooh. Uh, I'll do one calculation down here. By the way, students, the formula, the symbol for average speed is a V with a little bar over the top of it. That symbolizes average. Okay, so for Caitlin to Darion, it's delta x, the distance, over delta t, elapsed time, and that's 1.83 meters divided by 2.46 seconds. Okay, so that's going to be 0 point something meters per second. Can you calculate that out? Malara, did you? 1.83 divided by 2. You're my go-to person for calculations. Divided by 2.46. Who's got it? 0.743. Okay, anybody else verify that? 0.743? Okay, good. Let's write it down as 0.74 meters per second up here. 0.74. It's a hundredths of a meter per second. All right. All right, let's do the next one. 2.74 divided by 0.99. Now that's going to be about 2.7 something. Question? Focus. I don't know how to I have a hard time focusing because I can't really see it. And the control. Now there's a button here that says autofocus. Is that better? Is that better? No? I don't even know how to focus this thing. This is like a really old, 90s technology item. I don't. Wait a minute. Oh, here it is. All right, let me try this. Yo, dude, come on. Pay attention. You're the one that asked for it. Is that better? How about that? Is that better? Worse? It's not doing anything? Uh, I'll PDF it for sure. You mean you're in the third row? You can't even see it. I can barely see it from. Did you transcribe that? Let me see if I. This is pathetic. Maybe if I zoom in. Is that better? How about that? Better? I'll move the notebook up and down. All right. All right, let's do this one. 2.74 divided by 0.99. That's going to be about 2.7 something. 2.77. Malar, you verify that? 2.77? 2.74 divided by 1.08. This one's fluky. This is gonna be smaller velocity. 2.74 divided by 1.08. It's gonna be 2.6 or something. 2.537. Okay, that's 2.54. Okay, that is fluky. tape. All right, let me go back to. Okay, have we got the computer screen now? Okay. Thanks, boss. All right. Now, here's what we got to figure out. In the introduction, let me. Boy, I forgot to. In the introduction on page 10, it follows up that famous image of the football players with this question: what will the future state of the things that, what will be the future state of the things he sees? This is the classic question for a scientist. He wants to figure out the future. You know, where is that spacecraft going to go? You know, can I land it where I want on the moon or not? So to predict that, or the future state of the skateboarder, we need several items of data. Now, we've already recorded a bunch of it. Okay, position, and that encodes the distance and the direction. Now, we've only gone in one direction for this one, straight down the x-axis. But, you know, theoretically, like a spacecraft would go in 3 dimensions. So the position measurements record that. The velocity is encoded in the speed and direction of the object. So if you know its initial position and its initial velocity, you can predict the future velocity and position if you know one more thing, and that is the way in which the motion changes over time. We would call that a time evolution equation or an equation of motion. So if I know the position and velocity of a spacecraft at a given point in time, at a given point in space, and I know all the forces acting on it, I can figure out where it's going to go, at least for a few seconds. And then I have to make another calculation. All right? And so this is where we're heading, to figure out the future state of these skateboarders. And to do that, we have to know the acceleration. Acceleration is the quantity, it is a vector quantity that encodes the way that motion changes over time. Speed is the vector quantity that encodes the way that position changes over time. Acceleration encodes the way that the velocity changes over time. So velocity was delta x over delta t. Acceleration is going to be delta v over delta t. And homework 3 is going to, you're going to start taking some baby steps toward that. Now, before we dismiss, it's 1:15, time to dismiss. I have some good news and some bad news. The good news is we're going to have homework. But the bad news is that since there's a football game that I have tickets to on Thursday, we're going to cancel class on Thursday. So I'll see you guys next Tuesday. In fact, all of campus is canceling class. So I'll see you guys next Tuesday. Homework will be ready by sometime tomorrow. Okay.